Okay, so for the next section we're going to talk about what this comes down to cross-site scripting. And cross-site scripting is really injection of JavaScript into a web page. And I tackle this topic because a lot of times whenever pen testers go through and explain something, they generally don't do the greatest job of actually explaining why this is important or how it functions. And so what we're going to do today is we're going to take a look at kind of the base example, which is whenever you get a pen test, you usually get something that looks like this. Hey, we got some JavaScript on here, and then they can go through and show us if we inspect the item where we think it may exist. For example, this one, if we come down here and we can take a look, and we can see that there's in fact a script block in there that says hacked. Now that's fine, but it doesn't really get across the entirety of how dangerous cross-site scripting can be. So to complement that, we're actually going to take a look at another pen tester tool that's included with Kali Linux called BeEF. Now BeEF is kind of aging. A lot of the browsers are starting to catch up to it. Now that they've got automatic updates, it's getting a little bit less useful than it used to be, but it still does a fantastic job of what we're talking about here. So if we go back to a page and we check on one of the pages that has this script block in it, so we see here we've got our best ham ever, and if we inspect that element and take a look at that review, we'll see that as part of this review we've got a script block that's calling out to an IP address on 3000 with hook.js. And what that is it's a piece that's actually served up here as part of the BeEF service. So BeEF installs on a separate server that may be web-facing, and it exposes this JavaScript. Now what happens in the background of this, interestingly enough, is whenever we come over here and we take a look at this, we get a whole list of information about this and how it's working. Specifically, as we walk through here, we see some of the capabilities of the web browser that's been hooked, and we, for example, see it's Mozilla, it's running on Mac OS 10.14, and we've got the Firefox version. This is completely update as the time of the recording. It shows us the cookies for the site where we were currently logged in. If you notice, the AN ID actually allocates to the cart. And the auth token is actually the auth token for our current user. So if we go up here and we go to jwt.io and we plug this into our debugger, we'll see that we have a JWT, and not only is it exposing the Amazon username, but the person who built this clearly didn't understand how JWTs work and embedded the password as part of it. I've seen this in the past where developers have wanted to pass a password not understanding that the JWT acts as a functional signature for that. So coming back, we've got our browser cookie. At this point, we've got the password, so we don't really need anything, but we've got a whole bunch of other information that's here, right down to the graphics card that's actually installed on it. Okay, so some of the things that we can do with this is BeEF gives us a full listing of functionality that we can do to the browser. For example, we can go through and we can detect certain pieces. So for example, we can test to see if we have Foxit Reader installed, and it says no. Some of these are less effective. Over time they've started to fail out, but it gives us good feedback. It says anything that's here in green indicates that this is a task that we can run. That's undetectable to the user. The white indicates that it's unknown whether it will actually function or not. Orange will show us that it does function, but will report back to the user and has some behavior. And then the following items, red, are guaranteed not to work. But we have a whole list of options that are available to us, even going through and doing things simple as getting cookies. And it takes a second because in the background it's polling the server or the hooked browser and doing a callback to get that information. Now, it's interestingly enough that we can actually go through and do very malicious things in this. For example, let's go ahead and replace all of the locations on the page with our malicious address. Okay, so it says came back, rewrote 19 links. Now, no matter what I click on this page, it's going to take me to that address. Now, it's interesting to note also as part of this that we can come through and there are certain things that we can do to get persistence. So, for example, if we come up here to persistence, helps if I click on the right thing, man in the browser, if I click on this and we get a success, alright, so we are now hooked onto this. I can navigate back and forth through this website and still have access to everything that's going on. For example, we can also come through here and do things like read Gmail. Okay? But the more interesting part of this is that we can actually use this browser as a proxy. And it will allow us to request and make requests on behalf of the end user as part of this process. So anywhere that you've been, that you have valid cookies, I can now, as the attacker, navigate to using those cookies. That's a little bit of a quick breakdown as to why cross-site scripting is so damaging.